So before we did Riemann sums with left and right hand points, this time we're going to do midpoints and trapezoids. So we're going to estimate the area bounded by the x-axis, y equals x squared, x equals 0, and x equals 1. That's this shaded area right here, by the way. And we are going to use midpoints. So first thing we're going to want to do is we have n equals 4. We're going to break this up into 4 pieces. So this is 1/2, this is 1/4, and this is 3/4. This is 1, by the way, sorry if you can't see it. And as before, we had our width of our rectangle, delta x equals 1/4. So that's a good start if you can get that far. The next part is, I think it's a little hard to do. So rather than doing our left hand or our right hand rectangles, we're going to be doing midpoint rectangles. That means that my first rectangle is going to have a height of f of 1/8. It's going to be the y value at x equals 1/8. So it's going to be like that. By the way, between 1/4 and 1/2, that's going to be 3/8. So my second rectangle has a height of 3/8. So, and then you're going to keep doing that. It has a height of f of 3/8. You're going to keep on doing that. My next one has a height of f of 5/8, which, by the way, these are going to be whatever that x value is squared. And then my last one is going to have a height of 7/8 squared, which is f of 7/8. So these ones, mathematically, like algebraically, they're not very fun. I hope that you kind of understand the idea. So I'll give you the, I'm going to give you the formula for the midpoint sum. This may or may not be helpful for you, but I'm hoping that you can kind of understand what's going on with it at least. So my midpoint sum is going to look like this. And so this is my midpoint Riemann sum. Again, n is the number of partitions. In this case, we said the partitions were 4. This is my width. Actually, if you're at the point where you understand that the n is the number of partitions and that the delta x is the width, you're doing pretty well on this. And so this x sub I is going to be the midpoint of each interval. So it's x sub I actually with a bar over it. So it's a midpoint of each interval. So if we were to write this whole thing out, my midpoint sum would be, so the first term would be f of my midpoint of the first part, which is 1/8, times delta x, which we said was 1/4. That's the first thing from that sum. You'll notice that that's actually the area of this. We already said that the height was that y value, so this is my height, this is my width. And so then the second one is going to be f of 3/8 times 1/4, and so on. So it looks pretty unpleasant, and that's why I was saying previously, please use your calculator on these. You really don't want to be dealing with all of the possible mistakes. By the way, f of 1/8, that's going to be 1/8 squared because 1/8 squared because my equation is y equals x squared. So keep that in mind. And you're going to be working out this whole thing. Again, use your calculator. You don't want to be doing this by hand. I've gone through these problems and I've done everything by hand, and it's so easy to make a mistake. So please don't even bother doing that. Once we get the answer for this one, we should end up getting 0.328-ish. So this is actually a much better, I don't know if you remember from the previous videos, but the left Riemann was about 0.21, the right Riemann was about 0.46. This is right in between those, and this is a much better estimate than either of those two. And I'd imagine you're probably pretty sick of this same problem. However, believe it or not, this is one of the more basic problems I can give you. They could be much, much harder. We're not going to do a ton that are much, much harder because nowadays, since everybody has technology for everything, this is not as useful. Back in the 1600s or whatever, when Riemann was actually alive, it was a very useful thing. Now it's just more to understand where our future stuff comes from. So let's do this with a trapezoidal sum. I'm first going to give you the formula for trapezoidal sum. Actually, before anything else, I want to make sure that you remember that the area of a trapezoid is 1/2 times base 1 plus base 2 times height. So what we're going to do is we're going to split this off into our partitions, and we'll end up with 4 trapezoids. I'll show you the biggest one just so you could see it a little bit better. So this is going to be one of my trapezoids. This right here is my height, which in this case is my delta x, and it's equal to 1/4. So that's my height. Keep in mind that the height is actually sideways on our trapezoids here. And these are base 1 and base 2. So I think sometimes people, if they remember the trapezoid area, they get a little mixed up since the height is sideways. Don't let that bother you. Okay, so I'll give you the formula, and then we can talk about how that's related to the trapezoid area, and then we'll do a problem. We'll do the rest of this problem. So this is my general trapezoid area formula. It looks pretty bad, but I'm hoping that you can see that it does correspond with the area of a trapezoid. Our 1/2 is still there. We already said that the height was that delta x. This first function f of x to the I minus 1 is my first base. The other is the second base. So we are using the formula for a trapezoid. This sum, by the way, means we add up all those little trapezoids, in case you were confused about that for any of the Riemann sum formulas that we've seen. So let's go ahead and we'll do this problem. So you'll notice that I partitioned my function off into 4 trapezoids. The first one actually is a triangle because my first base is 0. That's fine. You're allowed to have that. So from there, you can either just find the area of each trapezoid individually. That's fine if you want to do it that way. Or you could try to use the whole formula. That's also fine. The key thing on these is just find a way that works for you. Everybody in the class might be doing something slightly different. That's okay. So let's go ahead. We'll work through the formula. I'm going to pull this 1/2 out front, and I'm going to pull this delta x out front. You're allowed to do that. So I'm going to pull the 1/2 out front. I'm going to pull my delta x, which is 1/4 out front. Then on the inside, I'm just going to have, I'll show you what this would be if you were to do that. Remember, with summations, we are allowed to do that. You're allowed to pull things out front. So on the inside, we're just going to have a bunch of stuff added together, a bunch of y values added together. That's what these f of x sub i's are. So my first thing is, so this is, we'll kind of color code this so you can see what's going on. My first one, I'm going to do it in green. My first base is 0. My upper base is going to be whatever f of 1/4 is. Actually, it's going to be 1/4 squared. My second trapezoid, the first base of that one is f of 1/4. The second base of that one is f of 1/2. And I'm not going to color code anymore. I'm hoping you get the idea though. So then my third one, I get f of 1/2 plus f of 3/4. And my fourth one, I get f of 3/4 plus f of 1. I'm always really happy in these problems when I have something that has a 0 or 1 because I'm just like, oh, thank you, God, for giving me something that's a little bit easier to deal with. So that 1/8 and the 1/4 multiply, or that 1/2 and 1/4 multiplied together gives me 1/8. Then from there, I can just simplify everything in here. So 0 plus 1/4, remember that's going to be 1/4 squared. F of 1/4 is 1/4 squared. This one is going to be 1/4 squared plus 1/2 squared. So that's my second one. I'm kind of chunking them together. Then I get 1/2 squared plus 3/4 squared. And then the third one is 3/4 squared plus 1 squared. Go ahead, you can do the whole thing on your calculator if you want. You will, in the end up getting, I think it ends up being, it's about 0.344. And this, I think, is the most exact answer. It's pretty close to your midpoint answer, but I think this is going to be the closest that you're going to get to the actual answer. I believe the answer is actually going to be 1/3. Thinking about, I just did it in my head, so I'm not 100% sure. I'll show you in the next section how to actually find that using integration, which is antiderivatives, and you're going to find that so much easier. But for now, this is a good start on Riemann sums. You can see the process that that mathematicians of the past did. They spent many, many, many years calculating all of these things, doing much more work than you or I just did. So I'm hoping you have some appreciation for that, and that you're happy you're happy like me that you get to use a calculator for everything nowadays.